Good evening everyone. Welcome to Tech Tutorials 2K21, the sixth day of C Programming Master Classes. So, in today's class, we will discuss about the arrays concept. We'll take an introduction part of an arrays. Then we'll see the definition of an array, how we are going to represent, how to declare an initialization of array, and then we'll see what are the different types of arrays we have. We'll go with the different examples. So I'll start with an introduction of an array. Simply, an array is a collection of homogeneous data items that can stored in a contiguous memory locations, and the elements can be accessed randomly using indexes of an array. Or else, an array is a collection of similar data items. So, in programming languages where the arrays concepts are existed are when in programming language, whenever we want to declare different variables of same data type, so simply we can use an extension of variable declaration like data type variable 1, 2, 3 and so on variable n. So when you declare like this, the increasing of variables can make you difficulty to use the variables for different purposes in programming languages. So whenever you have such situations, instead of declaring a multiple variables of same data type, we can use an arrays concept and which we can group all the similar data items and we'll put a single name. So we'll see how to declare an array by simply using a syntax like data type, array name and square brackets we have provided, and that square brackets is said to be a subscript, and within that subscript we have to specify the size. So here the data type is any of the primitive data types like integer, float, double and character. So whereas an arrays concept, it deals with the numerical values, so that we can use integer, float and double for an arrays representation. And the characters are also used for an arrays name, but that can be separately, we'll take a topic as a string. So for example of an array is, so here int is a data type and number is my array name, and within subscript I provide 25 is nothing but the size of this array, and the array is fixed size. So when the size is declared for your array, your compiler is going to reserve that many of locations specified by the array size. At the time of this declaration, the compiler will know how many items it needs to save, and then it has to decide how much memory it is reserved for arrays. So we'll see how the arrays are represented. So whatever the values we are placed inside an array, simply we can say array elements, and these elements are accessed in arrays by using their index, and array index is always starts from 0 and it ends with n minus 1. For example, if I take my array size is 10 So that is my n. So when I take my array size is 10, so the starting index I can take 0 and the index it will be n minus 1, that equals to 10 minus 1 is 9. So like this we have. So we can place all the indexes here. So when we take an array, and here this array name is marks. So these are the elements. So 35, 33, 42, 10, 14, 19, 27, 44, 26 and 31. So these are the elements I placed in my array. And each and every element is having some index, and this index will give you the position of an array element in the array declaration. So the starting index is 0 because the size of this array is 10. The last index is 9. So how we can access the array elements? So I already said the array elements can be accessed by their index. Suppose if I want to access 27. So now see, this is a value of 27. If I want to access this, I can use simply the index. So the index here for accessing 27 is 6. So simply I can take marks of 6 is going to access the element 27. Suppose we want to access 42. So simply the index is 2, so that we can say marks of 2 is equals to 42. And marks of 8 is equals to 26. Marks of 5 equals to 19. So like that we are going to access the array elements. And then after declaring an array, we need to initialize the values for an array. That is, we have to give an elements into array. So for that, we can say that is an initialization. So arrays can initialized as like a normal variables in two ways. One is compile time initialization and the second one is runtime initialization. So the syntax for compile time initialization is simply we can specify the data type array name is equals to is an assignment operator. Then in flower brackets we can specify the list of elements. So here is an example. My array name is number and the size of my array is 5. Suppose if I want to initialize my array values, that is of elements at compile time. So simply I can use this flower brackets, and within this flower brackets I can give my values, and each and every element is separated with comma. And after completion of my list of elements, I simply give a semicolon. Whereas runtime initialization, so arrays can also initialize at runtime, that is when program is executed by the user simply by using a scanf function. So in order to access some multiple elements from the keyboard, we need to use a loops concept. So we can use any loop. So by simply for arrays concept, anybody can use for loop. So this for loop is used to read multiple values from the user, and it is going to assign to an array. So simply we are going to use a for loop like I equals to 0, because I said already array index starts from 0, and then I is less than n I plus plus. So here n is a size. And in scanf statement, as like a normal scanf function for arrays also, we can specify the format specifier as one section and address of arrays are the second section. So this is an example how you are going to use the for loop to take an element at runtime for an array. So simply we can use for I equals to 0 and my n is 10 here. Suppose I am given. So I less than 10 I plus plus. Simply in scanf function. Suppose if I want to read an integer value, simply I can use percentile d and ampersand marks of I. So I will say the current index. So I will give you a small example. So how we are going to initialize the values at compile and runtime for an array. So how you are performing this reading and writing operations in arrays concept. So I just created one project. So here I am going to implement the arrays concept. So simply I am going to show you how to initialize compile time and run time, and then how to perform write operation. So I'm taken one array of type integer, and I'll put my array name is num, and the size of this array I will taken as, for example, 5. So that equals to, here I provided my list of elements, so I can provide like this 10 comma 25 comma 89 comma 78 comma 56. So these are the 5 elements I provided for my integer array. So now this array is going to store all integer values. So because your array is of type integer, it can hold only the integer values. And then I'll take one more array which is of type float, and then here my array name is marks. So I'll put my size is 5 for this array also, and simply I'm going to use this array for runtime initialization. So here I prompt the user, enter an array elements, and then here in scanf, so I want to read integer values. So here I need to provide ampersand, my array name is marks. So see here my array is of type floating point, I can give percentile f here, and then here I need to provide I. So simply I cannot read my array elements. So you have to remember, before giving this scanf statement, we must take one loop. So here I am using for loop, and I will take an integer variable I, which will controls my loop. I initialized with 0 because my index starts from 0, and I know my array size is 5, so I will give I is less than 5, and then I can use I++. And here in this function definition, I can give this scanf function. For read this floating point array. So my reading operation is completed. I am trying to display these two array elements. So for that also I need to display multiple values. So I can use loops again. The array num elements are. So if I want to take like an index like num of, so index is always an integer, so percentile d, and this value is coming from I actually. So I'll provide in that printf statement. So here I will take simply a heading. So I can provide like semicolon, and here I'm using my for loop to display all my values. So int I equals to 0 and I is less than 5, I plus plus. So in my function I can give my scanf statement like percentile d. Sorry, here I need to provide printf statement because I want to display, right? So simply I can give printf statement, and here num of percentile d, so is, I want to take that value, so I can use like this. So this num of the index value is coming from I, and the elements are coming from array num. So each and every index position I need to take a value, so simply I can use num of I semicolon. And this is for printing my first array element. So I can repeat the same thing for displaying my second array, and that array name is marks. So simply instead of this num I can provide marks elements are. So here it is the index is always like integer, so I can take like that only, and the values are floating point so that I can use percentile f. So here my array name is marks. So marks. Okay, marks. And here I need to write a values from the array marks. So simply I can provide like marks, marks of I. So my task is completed. Here I just read my one-dimensional array at compile time, and this is how we are going to give a values at runtime. So runtime. So simply we are going to use a standard function. So I just run this program. So I compile and run this program, and now you can see here our loop initial declarations are only allowed. Okay, so declaration I cannot do in this compiler itself here. So instead of I'm given int something here, I just declared my variable itself here, that is int I semicolon. So this is going to eliminate my problem. So I just again run this, and now you can see it will ask me an array element. So those are floating point. I will provide it like this: 4.48.9, 23.5, 78.2. And after that you can see the array num elements are num of 0 is 10, so which I assign at compile time, and these are the values we can see at runtime. So I just make a little bit formatting so that you can see the everything in a good format. So for that I am adding some more statements like printf. So here I'll give you like a heading, and then here every item I need to display in a next line, and I can add the same to here also. So when we are using percentile f, it will take 6 values after the decimal places. So you want to reduce that, we can use precision here. So I'll provide 0.2, means I'm requesting only I need after decimal places 2 values. So I just run this program again so that you can see the output in a better way. Expected semicolon before. Yes, I forgot to give a semicolon here. So for this statement and for this statement also like this. So semicolon is a termination, we must give to terminate. So here it will ask me, I'll give like 12.3, 56.2, 78.5, 47.6, 89.2. So now you can observe like the elements are. So okay, I'll make another little bit formats. So because I want to see everything in a good manner, like I can give \n, which makes the statements are displayed in next line. So here I provided like this, and here also I provided. So now execute. So the formatting we can do with your formatted input output statements. So it will give you that possibility. 78.2, 89.3, 45.1, and 56.2. So now see here. So the array num elements are num of 0 position is having a value 10, and num of 1 position is having value 25, and num of 2. So these are the indexes. So I already said the starting index is 0, and then n index is n minus 1. So here n is 5, so last index is 4. and it will place all the elements in this corresponding positions. And you can see here marks of 0 is 14.20, the first value which I entered, and the second is 78.20, and third is 89.30, and fourth is, that is in index 3 I have 45.10, and in last index I have 56.20. So this is how we are going to perform read and write operations on array. That is how to initialize your array elements at compile time and runtime. So now we'll continue, or we'll move to the next thing, that is different types of arrays. So depends on the number of subscripts so used in array declaration, and that can categorize the arrays into three different types. So the first one is a one-dimensional array. So as of now what we discussed. And the second is two-dimensional array, and the third one is a three-dimensional array. So we'll move with the definitions and in brief explanation of each and every array. So this is a one-dimensional array. So an array with a single subscript. So we can have only single square brackets. So then such type of array is said to be a one-dimensional array. So these are some examples. So that is float, sum, int, marks of 5, double, numbers of 6. So these are different array names. Sum, marks, numbers are different array names. So by using this first array, so I can take 10 floating point values and I can save under an array name sum. So whereas in my second example, so I can take 5 integer values and I can keep that 5 integer values in a single array name marks. So like this array is going to keep 6 decimal array, elements. So then how to calculate the size of an array? So if you take any array, so this is a formula for finding the size of an array. That is array size, we can take the number of elements we have in that array and multiplied with the size of the data type specified. So here is an example. So my array of type integer. So integer can take 2 bytes memory for a single integer value, and my array can hold 5 integers. So 5 multiplied with 2, now it will give me the size of this array is 10 bytes. So when I declare an array, so the compiler can know two things. One is what type of values I am going to give in my array, and then second, how much contiguous memory I am going to reserve for that array. So by this example, the compiler will know that okay, my array name is num and I can store 5 integer values there, and the size of this integer array is 10 bytes. So it will reserve 10 bytes as a contiguous memory locations. So as of now what we discussed, like how to declare and how to access and how to initialize, and everything will comes under the one dimensional array, so that I didn't explain again one more time. So we'll move on to the next array type, that is a two-dimensional array. So it simply says the name like an array with 2 subscripts. So whenever we have 2 square brackets, so then such type of array is said to be a two-dimensional array. So as like a one-dimensional array, we can declare two-dimensional array in a same way, but here we have to add one more subscript. So like data type, array name, and here 2 subscript. The first subscript will specify the row size and the second subscript will specify the column size. So when you have a two-dimensional representation, simply it will be a tabular form. So now we can have a tabular representation. It can have rows and columns. So the concept and everything is similar to your one-dimensional array. As like one-dimensional array, here also the index starts from 0 and ends with n minus 1. So here we have 2 dimensions, that is on row and column side. So row index and column index we have. So for that row index, it starts from 0 and ends with n minus 1. For column index also, it starts from 0 and ends with n minus 1. So here the data type, it will be any of the primitive data types that representing a numerical values like integer, float and double. And this two-dimensional array can be represented as a table. So this is a representation of two-dimensional array. So we can simply say this is your rows. These are the rows we have and these are the columns we have. And you can take this array and the size of this array is, so like we have 3 rows with 4 columns. So we can simply say, suppose this array name is number. So this array name. So I can have the first subscript of size 3 and the second subscript of size 4. And this is of type integer because it keeps integer values. So now this is my array. So for this array, this is my representation. Right, so this is my array and this my array name is num, and I have 3 rows and I have 4 columns. So when I have 3 rows, my index starts from 0 and it ends with 2 only, because 0, 1 and 2 will give you 3 indexes. For columns, so I have my column size is 4, so that my index starts from 0 and it ends with 3. So that is 0, 1, 2 and 3. So how we are going to represent each and every element position in 2-dimensional array is by their row index and column index. So now I can say this location is row 0 and column 0. So if my array name is A, this can be taken as A of 0, 0, and this position will be taken as A of 0, 0. And if you want to refer this position, so how you are going to take this position? This is your row 3, which is index having 2. So this is the second row and this is second column. So you can say A of 2, 2 is nothing but second row, second column. Right? So this is a row index and this is a column index. And these are the like the corresponding rows in that particular array. This is the first row, second row and third row. And how to access elements in 2-dimensional array? As like in 1-dimensional array, the 2-dimensional array elements are also accessed by their index only. If I want to access 30 and my index is A of 1, 1. If I want to access 50, so my index is A of 1, 3. If I want to access index 15, my index is A of 0, 0. So like this way, we can access the elements in 2-dimensional array. And how to calculate the size for this 2-dimensional array? So we have to take how many rows and columns we have. So depends on that we can find out the number of elements in your array. So for this, for example, so I have 3 rows, 4 columns. So totally I have 12 elements. And here my data type is integer. 12 into 2, 24 bytes I require to store this 2-dimensional array. So how to initialize this 2-dimensional array elements? So as like a 1-dimensional array, your 2-dimensional array elements are also initialized in 2 ways. So one is compile time and second one is runtime. So here it is a compile time initialization syntax, that is we can specify the data type, and this data type it may be integer, float, double or anything. And this is my array name and I have 2 subscripts, that is row size and column size. So now here in this flower braces, instead of I simply provided the list of elements, so I can provide these list of elements as a pairs, like row wise. So how many rows I have? So I can take that many of sets. Now you can see, suppose if I have n rows, so row 1 elements, and after that I can provide row 2 and then row 3 and so on, row n elements. So in each and every row elements is consisting of the number of columns, means that many of elements every row will consisting. Suppose see here is an example. So here my array name is marks and I have 2 rows, 3 columns. So each and every row consisting 3 elements. So now you can observe that this is my first row and this is my second row. So every row will consisting 3 elements. Right? So now 0th row I have these 3 elements at indexes 0, 1 and 2. And at first row I have these 3 indexes, these 3 elements at index 0, 1 and 2 as like this. Okay. And then for runtime, here it is a 2-dimensional. We have to specify the row and column. So for that, you have to use 2 for loops here instead of single for loop. Right? So here the first for loop will take the index of the row and second for loop is going to represent the column of the array. So now for simply a scanf statement, so here we need to provide two subscripts. So one is representing the index of row and another is representing the index of column. So I will show you with an example so that you can understand better. So I'll provide an example that is of simply I'm doing matrix addition here. So I will take two matrices, that is matrix A with a size 3 by 3. So matrix A of size 3 by 3, and I have matrix B of same size because I want to perform an addition. So simply I can take 3 by 3 matrix B. So here I will show you one array I am going to initialize at compile time and another I am going to initialize at runtime. So here it is like this. So simply I am given the values here. So simply I am using my assignment operator in flower braces. So I have 3 rows and every row is consisting 3 elements. So like this. So this is my first row. And then here it is my second row. And then I have a third row. So that is 45, 14 and 30. Semicolon. So this is my first array. So I initialized at compile time. So I have 3 rows, 3 columns and I'm taking 3 rows. So like this pairs and each and every row will consisting 3 values. And this is my second array. So I need to read these elements at runtime. So for that simply I am using 2 for loops. So one for loop is for row index and another is for column index. So before that I simply prompt the user enter elements for matrix B. And here I need to declare 2 variables because I need to use in my for loop. So here int I comma j. Scanf. So I need to take an integer value. Simply I can provide percentile d and ampersand b of ij. So before that I need to give my for loops here. So for I is 0 because my index starts from 0 and I less than 3 because my row size is 3, and then I plus plus, and in that I am writing one more for loop, that is a nesting of for loop. So for I'll take one more variable j and I initialized with 0 and j is also less than 3 because my column size is also 3, and then j plus plus. So here I need to provide my scanf statement because for reading an elements I have to know my row and column index. So this is a row index and this is a column index. So simply like this. So by this I just read all these things, and then now I'm going to add these two. I need one more array. So int c of 3 and 3 so is equals to 0. We can simply write here. So it will initialize all values with zeros. So or else it doesn't need because we have two array elements, right? So we can directly add and put the result there. So for adding also I need for loops, because I want to take each and every corresponding position of my matrices. So I don't need this statement. So I just remove this. And simply I am trying to add two array contents. So instead of scanf function here, I'm simply provide C of I, J, C of ij is equals to A of ij plus B of ij. So I simply add the corresponding index positions of A and B, and then I'll store that element in the corresponding position of C. And after that I need to print this result. So I can use again same for loops, because so instead of scanf I can use a printf statement here. So here I provide the result is so I'm using same for loops because I want to refer, and here I need to write a printf statement, and my result is at C. So I can print those integer values, and I want to display from my array C. So C of simply I can say I, and the second index is J. So semicolon. So here I need to provide a tab for horizontal spacing. I'll provide it like this. And then for every row after completion, if I want to take to the next line, so simply I can give here, because I will take the row representation. Here I am giving \n and then semicolon. So I think everything is perfect. So how these for loops are going to read your elements are, so initially it starts with 0 index, and 0 is less than 3 condition true, it come inside. So it will take your j index is also 0, and again 0 is less than 3. So it will take 0 and 0 as the first index, and it will place into the first index place. And after that, so remember always when the internal loop is terminated, then only it can see outer side loop. So as of now it will be in inner loop only. So and after that again your j get increment and it will take 1. So we remain at the same row and we incremented the column, so that we'll see 0 1 element and then 0 2 element, and after that j get increment, it becomes 3. So 3 less than 3 condition failed, so it terminated inner loop and it will see the outer loop. So I now get incremented and it will get 1. So 1 less than 3 condition is true. So now it is ready to read your row 1. So before that it read row 0. So now the row 1 also, by this column loop, it will take 0 index, 1 index and 2 index. So like this it will read all the elements, and after that by the same logic it is going to add two array elements at the respective indexes. And after that my result is at this array, so that I am going to display my result. So I just simply compile and run this program. So it will ask me elements for matrix B. So I need to provide 3 elements, 9 elements, because my array is 3 by 3. So now you can see the result is, so I'll provide for matrix A. So I will show you. So what are the values I provided for matrix A? So now you can see the first value is 12. So this 12 and 1 is added, my result is 13. 34 and 3 is added, my result is 37. 45 and 5 is added, my result is 50. So that it will take each and every row with that corresponding column value, and it is going to add with the second matrix. So this program will give you an information how you are going to initialize your two-dimensional array at both compile time and runtime, and how to access and how to do a matrix addition. So this is about a two-dimensional array. And then the third category of arrays are multi-dimensional arrays. So we can say multiple dimensional array is nothing but an array with more than 2 subscripts. So we can have more than 2 subscripts. That array is said to be a multi-dimensional array. So we can have 3 subscripts, 4 or 5 or something. When you have a multiple dimensional view, you can take a cube. So we can see in a different dimensions. So these 3-dimensional arrays are used to view your arrays in a multiple dimensions or else in a multiple views. And this multi-dimensional array, we can say it is an array of arrays. So simply the declaration of multiple array elements is an extension for your two-dimensional array. That is, simply we can provide data type and then array name, and here we need to provide 3 subscripts. The first one is a table number, and the second one is row size or as table size, and the second one is row size, and third one is column size. So this is a multi-dimensional array declaration syntax. So here also the data type, it will be of any of primitive data type like integer, float or double. So array name, it can be of any user defined name, and it's having 3 subscripts. The first subscript will specify the table size, and the second subscript will specify the row size, and the third will specify the column size. So now we can see, I said your multi-dimensional array can say it is array of array representations. Like it is a array of array representation. So we have 3 arrays. Again, every array will consisting 3 rows, 3 columns here. Now you can see this is, suppose we can say this array name is num. So now this is num of 3, 3, 3, because I have 3 tables, and each and every table will consisting 3 rows with 3 columns. So the accessing of these elements are similar to your 1 and 2 dimensional arrays. Like if I want to access this element, and this is my table index. So always any of the index, it starts from 0. So this is my table 0, and this is my table 1 and this is my table 2. So if I want to refer my table 1, so I can take index as 0. So then num of 0, so it represents this particular table. So from this table, I am going to take each and every row and column. So for this entire table, my index is 0 only. My first index is 0 only. And the next two indexes is going to be changed with respect to the rows and columns of this particular table. Suppose if I want to access this value, so we know this is 0th row, first row and second row. This is 0 column, first column and second column. So now I can take this value as 1, 1. Right? So this value as 1, 1 because this is my second row, right? The index is 1. So now if I want to access this value, so num of 0th table, first row, first column. So the value I can take num of 0, 1, 1. So that will give me this element. If I want to access this element, so now I can say this is my, suppose this is my third table. So index is 2. So in my index 2 table, I am going to access my first row, second column. The indexes of this row and column is 0 and 1. So I can take simply num of 2, 0, 1 will be the index of this element. So like that we can access any element from any table. So always the first index will say the table index and the second index will say the row index and the third will say the column index. So these multi-dimensional arrays can be used whenever we can view the data in a multiple dimensions. Right, not in a single dimension, like we can view the data in a different views. Then we go with this multi-dimensional arrays concept. So as like 1 and 2 dimensional arrays, the multiple dimensional arrays can also be initialized in two ways, that is compile time and runtime. So here we are using 3 dimensionals. We are going to use 3 for loops. The first for loop will say the table size, table index, and the second for loop is going to take the row indexes and the third for loop is going to take the column indexes, and the concept is similar, right? So we can use a simple scanf function. So there we can pass 3 index values, that is a of I, j and k. And for compile time we can use the same syntax like data type array name, and we can provide 3 subscripts is equals to. So there we can provide the flower braces, means the set of flower braces will be changed, like each and every set will consisting every table with inside the table every row and column representation. So in that way we can use a multi-dimensional arrays in C programming language. So I hope you all can understand. Thank you.